Hello, my name is Jackson Greencorum. This is my Physics 2211 Lab 2 titled Projectile Motion. Purpose of this lab is simple. We're testing the difference between physical motion and simulated motion by using a tracking software and comparing it to generated code. For this experiment, all we did was set up an object. I chose a tennis ball as my system, and then in the surrounding was the cloth hallway from a 1 meter height and tossed it. We videoed the object and uploaded it to the tracking software for analysis. Using Tracker, we mapped out the trajectory and recorded the data given, and then we translated the data into code using GlowScript. Setup, you can see to your left, the tennis ball is the blurry lime green object, and the trajectory is mapped out with the red diamonds. Now the code without the drag force is to your left, and the code with the drag force is to your right. And the outcomes are as shown. To your left, we have the tracker. We have a linear X trajectory and a non-linear Y trajectory, which is to be expected. We started at a meter, it went a little bit higher, and then it went all the way to 0 over the given time intervals. And the same can be seen to your right in the GlowScript code. Now, to your left, this is the GlowScript code with the drag force, with nothing too interesting is going on, but what happens here is odd. The values that I was given by GlowScript on our right do not match up at all when I plotted them in Excel. So as you can see, the orange and the navy blue are the tracker values, while the light blue, almost cyan, and dark green are the values that I was given by GlowScript. And as we can see, the Y values, for some reason, go all the way over here, and I'm not sure why. The equations that we were given or that we used are simple. The velocity update formula, the average velocity formula, the position update, and the two new ones, the drag force and the net force. We have to update our drag force with our given velocity formula so we can update our net force so that we can, again, update our velocity in an endless cycle, but that's how we iterate using physics and math so that we can constantly update our location and other qualities of the object in motion. Possible sources of error, well, we have human error, of course. I could have messed up using Tracker, or maybe a bit of my code is wrong. That could be possible given that GlowScript gave us such an outrageous response in Excel. Calculation error and physical error, that could play a bit into this. We assume that the ball is in free fall when in reality we start using a force of our hand in the initial toss that could be non-constant. So that doesn't factor into our calculations, but it should, and it could lead to error when talking about this lab. Time for the what if. So terminal velocity happens when a freely falling object experiences 0 net force. Examine the velocity versus time graphs predicted by my models. So the velocity versus time graphs, they do predict a terminal velocity, but it would have to go on for a much longer time period. Since my tennis ball only fell for a fraction of a second, it would be difficult to show terminal velocity. Now, imagine if the object were initially thrown straight up with the same initial speed. Would it take longer, shorter, or the same amount of time as my original experiment? It would take the same amount of time because the vertical trajectory of any object is independent from its horizontal trajectory. The same can be said for forces since we split everything up into three-dimensional vectors. And you can justify this using all of our equations and computations. And the concluding ideas is that the force from the initial toss possibly messed up some of our calculations, which leached its way into our code and into our final data tables. And again, the drag force in the GlowScript was new, but we saw that it did not change anything too drastically, and that all of our graphs, majority at least, matched up with what Tracker gave us and what we physically saw as the trajectory and motion of the tennis ball. Thank you very much.